So imagine someone hands you just a single piece of paper, and on it, there's a paragraph printed out. It's a completely normal, totally easy to read paragraph.
Hey, I'm picturing it.
Right. But right before they hand it to you, they run it through a paper shredder. So now they're handing you 10 distinct sentences, completely out of order, and they look at you and say, you have 20 minutes to put this back together. Go.
That sounds like an absolute nightmare, honestly.
I mean, it really does. And if you think about the math, if you have 10 individual sentences, there are over 3.5 million possible ways to arrange them, over 3.5 million combinations.
Right, so the odds are just astronomical.
Statistically, putting them back in the original perfect order without having seen the text beforehand, it should be nearly impossible. You'd expect just absolute chaos.
Yeah, just total random guessing.
Exactly. And yet, researchers actually ran this exact experiment. They handed this shredded document to a room full of college freshmen, and an overwhelming majority of them put it back together perfectly.
It's just wild.
They somehow navigated millions of incorrect possibilities and instinctively found the one true path. So today, we are taking a deep dive into the hidden cheat codes of human communication to find out exactly how they did it.
And it really is a remarkable phenomenon. I mean, it points to a reality about language that, well, most of us never consciously consider.
Because we just take it for granted, right?
Exactly. We spend years in school learning the rules of grammar, where to put comma, how to conjugate a verb. And the assumption is always that if the grammar is correct, the communication will be successful.
Right. If I use the right verb tense, you'll understand me.
But grammar is really just the surface level. It's the paint on the walls. The reason those students could reconstruct that text is because beneath the grammar, there is this invisible structural architecture to human thought.
And that architecture is exactly what we are exploring today. For this deep dive, we've pulled together an incredible stack of linguistic research, and it's all anchored by Michael Hoey's seminal work on the surface of discourse.
A truly brilliant piece of research.
It really is. It's basically a treasure trove. The mission today is to take apart the machinery of language. We want to understand why some writing, like an email or a news article or even just a post online, flows so effortlessly into your brain, while other writing, even when the grammar is totally flawless, feels like a miserable slog through waist-deep mud.
Yes, we've all read those emails where you just feel lost.
Oh, constantly. If you ever found yourself reading the same paragraph 3 times just to figure out what someone is trying to say, well, this research explains why, so let's jump in.
Let's do it. The core premise here is that sentences are not isolated islands. A sentence only actually has meaning based on how it connects to the sentences around it.
Right.
Discourse, which is the linguistic term for any stretch of language that is complete in itself, so whether that's a 2-sentence text message or a massive 1,000-page novel, it operates like a highly complex machine.
And the sentence is just one small cog in that machine.
Exactly. Our goal today is to lay all those gears out on the table and examine the invisible forces that lock them together.
Well, let's start with that paper shredder experiment I mentioned in the intro, because this completely shifts how I think about reading. I always assumed reading was just, absorbing words in a linear line.
Yes, left to right, one after the other.
Yeah. But this experiment suggests we have a subconscious blueprint for how ideas are supposed to be built. Walk me through the actual setup of this study.
So this was a landmark experiment conducted by Dr. E.O. Winter back in 1970. He wanted to prove that readers share a hidden consensus about how information should be organized. And the crucial part is, we share this even if no one ever formally taught us the rules.
Right. So what did he use for the text?
He created a highly logical 10-sentence text.
Mm-hmm.
And the subject matter was 2 national approaches to the problem of icy roads.
Okay, not exactly a thrilling beach read.
No, definitely not. But I suppose it needs to be dry and factual for the sake of the experiment, right?
Fair enough. Less distraction. So what did the text actually say?
It was a very straightforward comparison. The text explained that England relies on sand to treat icy roads. And that's perfectly fine for brief snowfalls, but it's highly inefficient for long, freezing winters.
Makes sense.
Norway, on the other hand, requires drivers to use steel-spike tires. This is fantastic for long, brutal winters. But the text notes that if you use spiked tires in England, they would absolutely destroy the road surface as soon as the snow melted.
Okay, so you have a very clear contrast. Nation A does this for this reason. Nation B does that for that reason. It has a natural symmetry to it.
It does. It's very balanced.
Yeah.
So Winter then took these 10 sentences, randomized their order entirely, and handed the jumbled list to 229 first-year university students.
That's a decent sample size.
Yes, and the demographic of these students is crucial here. They were studying computer science, chemistry, and engineering.
So they were not linguistics majors.
Not at all. They had never taken a class in discourse analysis. They were just regular, scientifically minded teenagers in their first week of college.
And he gives them 20 minutes to unjumble the 3.5 million possible permutations. I mean, I couldn't even sort my laundry in 20 minutes. To find the one correct narrative flow in that haystack seems like it would require pure luck.
It would, yeah, if sentence order were arbitrary. But it isn't. A staggering 55% of these students successfully reconstructed the entire text with 3 or fewer mistakes before the time ran out.
Wait, over half of them? That's incredible.
It really is. They instinctively understood the underlying architecture. They knew, without being able to articulate why, that the sentence about England's brief snowfalls had to follow the introduction of England's sand method. It couldn't just be placed next to Norway's spiked tires.
Okay, 55% is a massive success rate for something that statistically has a near zero probability. But I'm actually more interested in the 45% who failed.
Oh, really? Why is that?
Because if you have 3.5 million ways to get something wrong, you'd expect the failures to be completely scattered, right? Like one person puts the ending at the beginning, another person mixes the sand with the tires. It should just be pure noise.
That is the most revealing insight of Winter's entire study. The failures were not random noise.
They weren't.
Not at all.
Yeah.
Even when the students got the order wrong, they failed in highly uniform ways. Out of all those millions of incorrect permutations, the students repeatedly gravitated toward the exact same handful of incorrect patterns.
How does a wrong pattern emerge consistently? What were they doing?
Well, instead of alternating the contrast, saying, England does this, whereas Norway does this, some students would inadvertently group all the problem statements together first, and then group all the solution statements together at the end.
Ah, I see.
So the final text wasn't what the original author wrote, but it still maintained a rigorous, recognizable internal logic. It still made sense.
So even when they were wrong, they were still building a functional house. They might have put the kitchen where the living room was supposed to be, but they didn't put the toilet on the roof. They were still following a subconscious architectural code.
That is the perfect analogy. Winter called this a shared consensus about discourse. It's an unwritten contract between the writer and the reader.
A contract?
Yeah. The writer promises to organize the information in a recognizable pattern, and the reader uses their knowledge of those patterns to anticipate what is coming next.
I want to pause here and challenge the premise a bit, though.
Go for it.
Because when I look at a text about icy roads, I don't necessarily feel like I'm accessing some grand, invisible blueprint of human cognition. I feel like I'm just playing a matching game.
A matching game. How so?
Well, if sentence A ends by talking about, say, black ice, and sentence B begins with the phrase motorist skidding, I just click those two ideas together. It feels more like clicking Lego bricks together.
Okay, the Lego brick theory.
Right. I look at the end of one brick, find a word that matches the next brick, and snap them into place. Do we really need an overarching blueprint, or are we just making local, adjacent connections?
The brick-by-brick hypothesis. It is a very common and very intuitive assumption. And to be fair to your point, local connections do exist.
So I'm not totally off base.
No, not totally. In the Icy Roads text, one sentence ends by mentioning special steel spike tires, and the very next sentence begins, these tires. That is a clear adjacent lexical link. You are snapping the Lego bricks together.
Right. So why isn't that enough to explain how we read and write?
Because if discourse were truly just a chain of adjacent links, you wouldn't need a master plan at all. You would only ever need to look at the sentence immediately in front of you to know what to write next.
Sure, because the chain just keeps building itself.
Exactly. And linguists actually tested this exact theory using a variation of a parlor game called Serious Consequences.
I love a good academic party game. How does this work?
You might be familiar with the childhood game of consequences. Someone writes a sentence on a piece of paper, folds it over so only the last few words are visible, and passes it to the next person.
Oh, yeah. And the next person adds a sentence, folds it, and passes it on. The end result is usually a comically absurd, disjointed story.
Right, because nobody knows what the first person wrote.
So how did the linguists change it?
In the linguistic version, Serious Consequences, they tweak the rules to test your Lego brick theory. Person A writes a sentence. Person B is allowed to read person A's entire sentence.
Okay, so they see the whole brick.
Yes. Person B must then write a sentence that logically, naturally, and grammatically follows person A's sentence. Then person B folds the paper so person A's sentence is completely hidden, leaving only person B's sentence visible for the next person.
Oh, I see. So person C reads person B's sentence and writes a logical follow-up to that.
Exactly. This is the ultimate test of the adjacent link. Every single person is looking at the immediate Lego brick in front of them and carefully snapping a new brick onto it. There are no broken links. Every sentence makes perfect sense in relation to the one immediately before it.
So if the Lego theory holds up, we should get a perfectly coherent, if slightly unoriginal story. What actually happened?
Total catastrophic failure of meaning.
Really?
Oh, the resulting texts were absolute gibberish. Let me read you an example generated from a starting sentence about epitaphs on monuments.
Please do.
So the text they produced went like this. It needs scarcely be said that an epitaph presupposes a monument. It is very rare to find a monument on which there is no epitaph. Usually there is some hackneyed phrase. In this case, though, the deceased would have been proud of the epitaph. He would even have chosen it for himself. Why then didn't she appreciate it?
Wait, why then didn't she appreciate it? Who is she? Where did this woman come from?
There is no she. Person E saw person D right. He would even have chosen it for himself. And person E thought, well, a logical follow-up to a man choosing something for himself is a woman not appreciating it. So they added the she.
Oh, wow.
But because person E couldn't see the beginning of the paragraph, they couldn't see the overarching blueprint, they derailed the entire discourse.
I see. Every single sentence makes sense next to its immediate neighbor. But when you zoom out and look at the paragraph as a whole, it's a disaster.
Exactly.
It's like building a house where the plumber only looks at the pipes in one room and the electrician only looks at the wires in the next room, and you end up with a staircase that leads directly into a bathtub.
That is the perfect visualization. Human discourse is not a chain. It is a structured hierarchy. A writer must be aiming at a broader destination. The meaning of any given sentence is governed not just by the sentence next to it, but by the intention of the entire text. You cannot create coherence without a blueprint.
Okay, you've dismantled the Lego theory. I admit defeat.
Well, the linguist dismantled it. I'm just the messenger.
Fair enough. But I want to really test how deep this blueprint goes, because even in that epitaph example, they are still relying on words. They are relying on nouns and verbs to track the meaning. Take away the vocabulary, and surely the blueprint vanishes, right?
You would definitely think so. But researchers, Richard Young and Alton Becker, performed an astonishing experiment that proves the blueprint exists independently of the vocabulary.
Really? How do you even test that?
They were studying paragraphing.
Yeah.
You know, how do we know when to start a new paragraph?
Usually when the topic changes, right?
Right. They took a historical essay comparing two American Civil War generals, Ulysses S. Grant and Robert E. Lee. First, they removed all the paragraph indentations. They presented the essay to readers as one massive, unbroken block of text and asked them, where should the paragraph breaks go?
And I'm assuming the readers easily found the breaks based on when the authors stopped talking about Grant and started talking about Lee?
They did. There's almost total unanimity. But then, Young and Becker did something truly radical. They created a second version of the text.
Okay, what did they change?
They kept all the structural grammar, the commas, the periods, the conjunctions like and or but. But they replaced every single noun, verb, and descriptive adjective with pure Lewis Carroll-style nonsense words.
Wait, I actually have a printout of this second version from the research notes, and it looks like an alien language.
It does, doesn't it?
Let me try to read the opening lines of this version. Blog was moked by Grolnards, the wilest nerg of the liver mulk. He was dreed and bams above any nerg on either deer as an alaib cosliest. It is completely incomprehensible. Livar mulk, Grolnards.
All lexical meaning has been stripped away. Grant has become blog. Civil War has become Livar Moke. They handed this block of pure nonsense to a new group of readers and asked them to find the paragraph breaks.
But how could they? If they don't know what a nerg is, how do they know when the author stops talking about it?
That is the genius of the experiment. The readers still unanimously agreed on exactly where the paragraph breaks should go.
You're kidding! They found the breaks in the nonsense text. But how?
Because our brains are not just tracking the topic. We are tracking structural signals, grammatical shifts, pronoun references, and transition markers that operate entirely independently of the specific vocabulary.
Oh, I see.
When he shifts to a new nonsense subject, or when a sentence begins with however, our brain registers a structural pivot. The blueprint is real, and it is so deeply ingrained in us that we can detect it even when the house is made of invisible materials.
That is profoundly weird, but also incredibly cool. It means reading isn't just absorbing facts, it's feeling the rhythm of the logic.
Yes, feeling the rhythm is a great way to put it.
So if we all have this subconscious software running in our heads, how do we make it conscious? We promise to take the machine apart and look at the gears. How did these sentences actually lock together in the reader's mind?
To understand the gears, we have to look at what Dr. Winter defines as the clause relation. This is the foundational building block of all human discourse.
Clause relation. Okay.
And the most important thing to grasp here is that a clause relation is not a grammatical rule printed on the page. It is a cognitive process happening inside your head.
Okay, unpack that for me. What do you mean it's not on the page?
A clause relation is the process by which a reader interprets the meaning of a sentence in light of its adjoining sentences. When two pieces of language are placed together, if the meaning they create together is more than the sum total of their separate parts, they are in a relation.
Can you give me an example?
Sure. For example, if I say to you, "It rained. The streets are wet."
My brain automatically connects those two things. The streets are wet because it rained.
Yes, but notice that the word because is nowhere in those two sentences. It rained. The streets are wet. The causal link does not exist on the page.
Oh, you're right.
You, the reader, supplied the cause and effect relationship based on your understanding of the world. You actively performed a cognitive interpretation. That unseen link is the clause relation.
So the writer sets up the dominoes, but the reader is the one who actually knocks them down in their mind.
Exactly. And the sources say these relations generally fall into a few major categories. Broadly speaking, they divide into logical sequence relations and matching relations.
Okay, let's break those down. What's a logical sequence?
Logical sequence is about events or ideas happening in time or causing one another. Things like cause and consequence or condition and consequence. If you drop the glass, it will break. Time and logic.
Got it. And what about matching relations?
Matching is about comparing statements to highlight similarities or differences. It's not about sequence in time. It's about side-by-side comparison, contrast, and compatibility.
Okay, so as a writer, if I'm relying on the reader to do the cognitive work of connecting these ideas, I have to make sure I'm giving them the right clues. If I just list a bunch of unrelated facts, the reader's brain is going to short-circuit trying to find the invisible because.
Absolutely.
So what is the toolkit for making these connections obvious?
The most obvious tools are explicit grammatical signals. Linguists call them subordinators and conjuncts, but in plain English, we're talking about transition words. Because, while, therefore, however, subsequently.
It's a classic signposts.
Exactly. These are the overt road signs that tell the reader exactly what kind of clause relation they're supposed to form in their mind.
But the research points out that relying entirely on therefore and however makes your writing sound like a legal contract, right? It gets really clunky.
It does. It can feel very robotic.
There's a more subtle tool they highlight called lexical signals, actual vocabulary words that do the structural heavy lifting in disguise.
Yes, lexical signals are fascinating because they are words that seem purely descriptive, but are actually firing a flare gun into the sky to alert the reader of an upcoming structure. The text provides a great example about the city of Birmingham.
Right, let's look at that one. The first sentence is, people think of Birmingham in different ways.
Now, if we look at the word different in that sentence, it functions as an adjective describing the ways people think. But structurally, it is doing much more.
What is it doing structurally?
The word different is a lexical signal that forces an expectation upon the reader. It tells your brain, get ready, I'm about to give you a matching contrast relation.
Oh, because if you say different, my brain demands to know what those different things are.
Exactly. And the very next sentence delivers on that promise. Alderman Frank Price sees the city as a sort of anvil, whereas my barber thinks of it as a neutral sort of place. The contrast is fulfilled.
This reveals something crucial about fluency. Reading is an active, anticipatory process. The writer drops clues, like the word different, and the reader forms subconscious expectations.
Yes, and when the writer fulfills those expectations, the text feels like it flows. When the writer fails to fulfill them, the text feels muddy and confusing.
Which brings me to what I think is the most actionable, brilliant concept in this entire stack of research, Dr. Winter's interactive method.
Oh, this is a great one.
The idea that to truly test if your writing flows, you have to project your monologue into a dialogue. You have to pretend the text is actually a transcript of an interview, and you have to find the invisible questions.
It is a brilliantly simple analytical tool. It forces you to view your own writing from the perspective of the anticipating reader.
Let's apply this. The sources use a tiny excerpt from an Enid Blyton children's story. 2 sentences. Peter went red. He knew he had been silly. Just 2 statements of fact, no connecting words, no because or therefore.
Right.
But if we role play this as an interview, the structure lights up.
Exactly. You act as the invisible interviewer. The writer says the first sentence, Peter went red. Now you, the interviewer, must ask a natural follow-up question based on that statement. What would you ask?
Well, if someone tells me a kid turned red, my immediate question is why? What caused that?
And the writer's second sentence provides the answer. He knew he had been silly. By identifying the invisible question, why? You have exposed the hidden cause-consequence relation.
Wow.
The first sentence is the consequence. The second sentence is the cause, answering the implicit question.
I want everyone listening to try this. Pull up an email you wrote recently or a presentation you're working on. Read the first sentence out loud, then stop. Ask yourself, what question is my reader instinctively asking right now based on what I just said?
It's such a helpful exercise.
Are they asking what's the problem? Or give me an example? Or how do we fix this? Then look at your next sentence. Does it answer that specific question? If your reader is asking, why did sales drop? And your next sentence answers, here is our new marketing slogan, you have broken the invisible chain. You left their question hanging in the void.
That is the root cause of the miserable slog. If the logical progression of anticipated questions is broken, the discourse breaks down, no matter how perfect the grammar is.
So if reading is essentially just a silent dialogue where we answer invisible questions, it makes me wonder, are we all asking the same questions? Is there a universal formula our brains default to when we try to process information?
There is. And it governs a massive portion of the English language, particularly in nonfiction, journalism, and science. The researchers call it the problem-solution pattern. It is the ultimate overarching blueprint.
The sources use a highly stripped-down 4-sentence story to map this out, the sentry duty text. It's almost comically simple, but it perfectly illustrates the skeleton of this pattern. Let's break it down.
Okay, so the story is, I was on sentry duty, I saw the enemy approaching, I opened fire, I beat off the attack.
4 punchy sentences. Let's map the cognitive architecture.
Sentence 1, I was on sentry duty. This establishes the foundational reality. In discourse terms, this is the situation. It tells the reader the context.
Right, so that's the setup.
Sentence 2, I saw the enemy approaching. This introduces a complication to the context. This is the problem.
The conflict.
Sentence 3, I opened fire. This is the action taken to resolve the complication. The response. Sentence 4, I beat off the attack. This is the outcome of the action, the result. But crucially, it also contains a positive evaluation of the response. Beating off an attack is a success.
So the whole flow is situation, problem, response, result.
Exactly.
Now, a skeptic might look at that and say, well, obviously it's written in that order because that's the chronological order in which it happened. Time dictates the structure, not some linguistic blueprint. But the research proves that the sequence itself carries meaning, right? What happens if we mess with the order?
Let's test the skeptic's theory. Let's try putting the response before the problem while keeping the exact same grammar. I opened fire. I saw the enemy approaching.
That completely changes the meaning. Now, it sounds like you randomly started shooting into the dark and then you happened to see the enemy. Or worse, it sounds like the act of opening fire somehow caused the enemy to appear.
Precisely. By altering the unmarked chronological sequence of the problem-solution pattern, you destroy the natural clause relation.
The invisible link breaks.
Yes. If a writer genuinely wants to present the response before the problem, they cannot rely on the reader's invisible assumptions. They have to use explicit grammatical glue to force the meaning back in. They would have to write, I opened fire because I saw the enemy approaching.
The word because has to do the heavy lifting that the structure used to do for free.
Which proves that the sequence of situation, problem, response, result is a cognitive structure in its own right. It is a universal formula we use to process action.
Okay, I buy that it works for a simplified 4-sentence example about a soldier. But does this actually scale up to complex adult writing? Does scientific white paper use the same blueprint as I was on sentry duty?
It scales up flawlessly.
Okay.
To prove this, Michael Hoey's research applies this exact framework to a highly technical article published in the New Scientist magazine.
Okay, let's look at that.
The subject matter is completely different. It's an engineering article about helicopters dropping freight.
Let's trace the blueprint in the wild. How does the article start?
The article begins with a broad paragraph. noting that helicopters are incredibly convenient vehicles for dropping freight via parachute into remote areas. That is the situation. It establishes the context.
Just like being on sentry duty.
Exactly. But then the text introduces a physics complication. Somehow, the immense landing impact of the heavy freight has to be cushioned to prevent the cargo from being destroyed.
So the enemy is approaching. We have our problem.
Exactly. A delicate situation requiring a solution. The reader instinctively asks the invisible question, what is the response to this problem? The text answers by introducing a French engineer named Birkin who has developed a novel air cushion platform. That is the response.
The engineer opened fire.
And finally, the text provides data detailing how this air cushion platform reduces deceleration forces and successfully handles up to 8 tons of freight without needing a parachute at all. That is the result, and because it succeeded, it serves as a highly positive evaluation of Bertin's response.
That is wild. It's the exact same 4-part skeleton. Situation. Dropping freight. Problem. It hits the ground too hard. Response. Build an air cushion. Result. It lands softly. It's the sentry duty architecture dressed up in a lab coat and scientific vocabulary.
And this leads us to what might be the deepest philosophical insight in the entire book.
Want to do tell?
When you strip away all the complexity of human communication, discourse researchers argue that there are really only 2 bedrock units of human perception. Everything we say boils down to these 2 atoms.
Yeah.
Situation and evaluation.
Facts and our feelings about the facts.
Yes, knowing and thinking. Consider what a problem actually is. A problem is not an objective physical reality in the universe. It is merely a factual situation combined with a negative evaluation by a human being.
Wait, really?
Think about it. The enemy is approaching is objectively just a statement of mass and velocity. It only becomes a problem because the sentry evaluates it negatively. He does not want to die.
Oh, wow. So the physical world just is. We create the problem through our negative evaluation of it.
Exactly. And similarly, a solution is not a physical object. A solution is simply a factual response combined with a positive evaluation. I beat off the attack. The action was successful. It resolved the negative situation. Therefore, it is a solution.
That is incredibly profound. We literally construct our narrative reality through this interplay of stating facts and evaluating them. But as much as I love the problem-solution pattern, it can't be the only way we communicate.
It isn't now.
Sometimes we aren't trying to fix a problem. Sometimes we are just trying to describe a landscape or compare 2 historical figures or explain how a machine works. How do we structure those thoughts?
That brings us to the other major architectural branch, matching and general particular patterns. If problem-solution is the engine we use to navigate action and conflict, matching and general particular are the tools we use to navigate description, classification in detail.
Let's unpack matching first. How does this differ from logical sequence?
A matching relation occurs when a writer holds 2 parts of a discourse up next to each other to compare their details. If we go back to our invisible interviewer, a matching relation answers the broad question, is what is true of X also true of Y?
And obviously the answer to that question can be either yes or no, which gives us compatibility or contrast.
Let's look at an example of matching compatibility. The source text examines a passage about iconic models. It states that a geographical map will only contain those specific features which are of interest to the person using the map.
Okay.
Then it follows up by saying that, similarly, an architect's scale model will only include features of interest to the person employing the architect.
Map makers and architects, they are being matched for similarity, and the author uses the lexical signal similarly to ensure the reader knows to connect them.
Yes. But matching can also be used for contrast to highlight differences.
Yeah.
And this isn't just for dry technical manuals. The researchers demonstrate how literary artists use these exact same clause relations to evoke emotion.
Literary artists.
They analyze William Blake's 18th century poem, The Clod and the Pebble.
I really didn't expect discourse analysis to veer into romantic poetry, but I am here for it. How does Blake use match and contrast?
The poem explores 2 opposing views on the nature of love. The first stanza is spoken by a selfless little clod of clay. It says, "Love seeketh not itself to please, nor for itself hath any care, but for another gives its ease, and builds a heaven in hell's despair."
So the clay believes love is entirely altruistic.
But then, skipping the third stanza, we hear the opposing view from a hard pebble of the brook. It says, "Love seeketh only self to please, to bind another to its delight, joys in another's loss of ease, and builds a hell in heaven's despite."
The structure of that is identical, but the meaning is the exact inverse. It's incredibly striking.
What Blake is doing there is heavily utilizing syntactic parallelism. He's using the exact same grammatical skeleton to force the reader to feel the contrast.
Love seeketh not itself directly matches and contrasts with love seeketh only self.
Exactly. And builds a heaven and hell's despair is the perfect structural mirror to builds a hell and heaven's despite.
So syntactic parallelism is basically taking the scaffolding of one sentence and reusing it with opposite words. Because the rhythm is the same, our brain physically feels the contrast much harder than if he had just said, the clay is nice, but the pebble is mean.
Exactly. The grammatical structure itself is mirroring the thematic opposition of the two elements. The rules of discourse aren't just constraints. They are the strings that artists pull to make us feel things.
Okay, so we can solve problems and we can compare things. But what about when a writer is trying to unfold a really complex hierarchy of facts, like a journalist explaining a corporate scandal or an author revealing a mystery? How do we drill down into the details without losing the reader?
For that, we rely on the general-particular relation. This is the mechanism we use to zoom in. It usually takes the form of a broad generalization followed by specific examples, or a high-level preview followed by granular details.
The sources pull a great example of this from a detective story by Christopher Bush called The Hampstead Murder, right?
They do. The author begins the paragraph with a broad, generalizing statement. The great men of Scotland Yard are human. Now, what is the invisible question the reader instantly asks?
Give me an example of how they are human. Or maybe prove it.
And the author immediately delivers. He follows that general statement with a series of finely matched specific examples of their human failures. He writes that one great detective might forget a match, another might miss a clue, another might overlook a footprint.
So the general statement is the trunk of the tree, and the specific examples are the branches.
That is precisely the terminology the researchers use. They call it a detail tree. It's a complex hierarchy where one general preview branches out into meticulously matched specific details.
A detail tree, I like that.
It is how human beings organize overwhelming amounts of complex information into digestible, logical chunks. You give the reader the big picture, and then you safely guide them down into the weeds.
Okay, I need to push back heavily here.
Go ahead.
Because all of this, the sentry duty, the detailed trees, the perfectly matched poems, it all sounds incredibly neat and tidy. It implies that human thought is a perfectly organized filing cabinet. But my thought process is not a filing cabinet. It's a messy junk drawer.
That's a fair point.
We go on tangents, we circle back to things, we write out of order. Is discourse really this perfectly hierarchical in the real world? If I write a long email, am I really just building a flawless detail tree?
That is a very valid critique, and it is exactly the issue Michael Hoey addresses in the final theoretical conclusions of the book. And the answer is no. Discourse is not a strict top-down tree. In reality, it is a nonlinear network. It is chaotic.
A network, what does that mean in practice?
It means that sentences do not just connect to the sentence immediately before or after them, they cross-pollinate. If you take a very simple passage of just 4 clauses, let's call them A, B, C, and D, the relationships are not just A to B and C to D.
How else do they connect?
Clause A might have a causal relationship with B, a contrasting relationship with C, and serve as an example for D.
Wait, if every clause can potentially relate to every other clause in multiple ways, how many connections are we talking about in just 4 sentences?
Researchers calculated the mathematical potential. In a simple 4-clause text, there are potentially 96 different internal relationships operating simultaneously.
96 relationships. In 4 sentences, if I write a 10-page report, the math on that must be astronomical. Why do we need a magnifying glass to look at 96 relationships if our brains just naturally process it anyway? Isn't this theory just overcomplicating something we do instinctively?
We don't process all 96 relationships consciously. If we did, our brains would melt. It is a massive, multi-dimensional web of meaning. The reason the theory matters is because it explains the role of the writer.
What is the writer's job then?
The writer's job is to navigate the reader through that chaos. They survive the 96 relation jungle by using what linguists call focusing signals.
Focusing signals. Okay, how does that save us from the jungle?
Think of the 96 relations as all the possible tangled paths through a dense underbrush. The writer uses grammatical signals, lexical cues, and culturally approved patterns, like the problem-solution blueprint, as a machete.
A machete.
Yes. They hack a single linear path through that non-linear web of thoughts. They focus your attention on the specific relationships they want you to see. while the other 95 relationships hum quietly in the background, providing subconscious texture and context.
Oh. So when reading feels like a miserable slog, it's because the writer dropped their machete. They didn't provide enough focusing signals. They just dumped me in the middle of a 96 relation jungle without a map and expected me to hack my own way out.
That is exactly what happens. Bad writing is a failure to guide the reader linearly through a nonlinear thought process. And understanding this architecture isn't just an academic parlor trick for grading college essays. It has incredibly high-stakes applications in the real world.
Which brings us to the payoff at the end of the sources, which I found absolutely fascinating. The linguists studying this, people like Robert Longacre, John Beekman, and John Callow, they weren't just analyzing detective stories or engineering magazines. They were using this science for something monumental.
They were. They applied these discourse analysis techniques to the translation of deeply complex ancient texts. Specifically, they used it to translate the Bible into modern languages, focusing on intricate books like the Acts of the Apostles and the Epistle of Jude.
Now, just to be clear for you listening, we aren't diving into the theology of the text here, but rather the sheer monumental linguistic challenge of what these translators were facing.
The linguistic challenge is staggering. When you are trying to translate an ancient text into a modern language, especially an indigenous language that might belong to a completely different language family with entirely different grammatical structures, you simply cannot translate word for word.
Because the Lego bricks of ancient Greek or Hebrew don't fit the studs of a modern tribal language in South America. The grammar doesn't align.
Exactly. If you translate word for word across language families, you produce the exact same kind of catastrophic gibberish we saw in the Serious Consequences game. The local links might hold, but the overarching meaning is destroyed.
So how does discourse analysis solve the translation problem?
Longacre, Beekman, and Callow realized that to accurately convey the meaning across massive cultural and temporal divides, you have to decode the underlying propositions first. You can't start with a vocabulary. You have to find the invisible architecture.
So what does that look like in practice?
You look at an ancient paragraph and ask, is this a cause-consequence relation? Is it a general particular detail tree? What is the invisible question the original author was answering?
You map the blueprint of the house before you start moving the furniture.
Yes. Once you map the deep discourse network of the original text, once you see the problem-solution loop or the matching contrast pattern, you can then rebuild those exact same conceptual relations using the unique grammatical tools of the target language.
So the meaning survives even if the grammar completely changes.
The vocabulary changes, the grammar changes, but the clause relations remain intact. Discourse analysis becomes the ultimate decoding key for human history and cross-cultural communication.
That is absolutely staggering. It implies that beneath the surface of English and ancient Greek and Norwegian and every other language on Earth, we share this fundamental, deep cognitive architecture of logic. The paint on the walls looks different in every country, but the structural studs are in the exact same place.
It is the invisible thread that binds us together as a communicative species.
So let's synthesize all of this. What we've learned today completely redefines what reading actually is. Writing is not a passive intake of data. It is not just running your eyes over a string of Lego blocks. It is an intense, highly active, silent interaction.
The Sarban dialogue.
Yes, a continuous dialogue where you, the reader, are constantly anticipating the writer's answers to your own invisible questions. If the writer anticipates your questions correctly and provides the machete to guide you through the network, the text flows like water. If they don't, the machine grinds to a halt.
That is an excellent summary of the mechanics. But I will leave you with one final, slightly provocative thought to mull over regarding this invisible architecture.
I'm ready. Lay it on me.
In the book, Hoey includes an example of a text generated by a highly primitive computer program from 1978.
1978, okay.
The computer was playing a simple game of noughts and crosses, what we call tic-tac-toe. And as it made its moves, it was programmed to generate a descriptive text of the game's progress.
Okay, a 1970s computer describing tic-tac-toe.
Even though the computer was primitive and had absolutely zero programming regarding complex human emotions, literary ambitions, or discourse theory, the text it naturally generated fell perfectly into the exact problem-solution patterns we've been discussing.
Really? How?
It evaluated a threat on the board, which is a problem. It placed an X to block it, which is a response, and it noted the outcome. The result.
Wait, a 1970s tic-tac-toe program spontaneously generated the exact same cognitive discourse architecture as the Sentry Duty story.
It did. Which raises a fascinating, perhaps unsettling philosophical question. If our most complex, emotional, and persuasive discourses, from William Blake's romantic poetry to intricate historical narratives, can ultimately be boiled down to a finite set of anticipated questions and clause relations, does that mean true? Unbounded creativity in writing is just an illusion.
Oh, wow.
Are we all, at our core, just highly advanced biological algorithms executing the exact same problem solution code every time we open our mouths to speak?
Wow. That is terrifyingly plausible. Are we just running the Sentry Duty script over and over in different fonts for our entire lives? That is a massive question, and it is something I'm going to be thinking about all winter. Thank you so much for taking this deep dive with us today. The next time you find yourself flying effortlessly through a brilliant article or drowning in the muddy slog of a confusing email, you won't just be looking at the grammar, you'll be looking right through the walls, seeing the invisible plumbing and the hidden architecture, knowing exactly what's happening just beneath the surface of the discourse.